Those are the 6.1 and 6.2 notes, exponential functions and graphs, page 2. So we want to start by rewriting these as a times b to the x form. Sometimes you got to manipulate the exponents to put this in a form that is a little more useful. So we're going to go back to some of the rules from that last page. This can be written as the cube root of 27 to the x. Keep in mind that I can view this as 27 to the x to the 1/3, which is kind of how I've written it there, or 27 to the 1/3 to the x, which might be a little more useful. So I'm going to rewrite this as the cube root of 27, all to the x power, which makes this 3 to the x. Because our base greater than 1, so this is a growth function. B, I have g of x equals 5 times 3 to the negative x. Here I'm going to use the properties of that negative exponent. This becomes 1/3 to the positive x. So keep in mind, 3 to the negative x, we could rewrite as 1/3 to the x. And the one thing that we don't talk about enough is that 1 to any power is still 1. So we can think of this as 1 to the x over 3 to the x, which gives us 1/3 to the x. 1/3 is positive, but it's less than 1. So this is a decay function. H of x, we've got 5 to the x plus 2. Remember, our exponent should just be x. So I'm going to rewrite this as 5 to the x times 5 squared. And then I'm going to reverse the order. 5 squared is 25. I get 25 times 5 to the x. 5 is greater than 1, so this is growth. K of x equals 1/2 times 3 to the negative x minus 1. Whole lot to unpack there. So I'm going to see if I can do this in pieces. I've got 3 to the negative x times 3 to the negative 1. Negative x plus negative 1 gives me that minus x minus 1 that's in that exponent. I get 1/2, just like we had above, 1/3 to the x times 1/3 to the 1. Multiply my 1/2 and 1/3, I get 1/6 times 1/3 to the x. 1/3 is less than 1, so this is decay. Okay? So exponential functions has to have an x as the exponent. Okay, so here's our form, a times b to the x. And hopefully, as you saw above, we typically can isolate the x in that exponent. So a times b to the x, a is the initial value. We don't want that to be 0, otherwise everything's 0. B has to be a positive number and not equal to 1. I mean, it could equal 1, but then it's kind of boring because 1 to any power is just 1. That becomes a constant function. The domain of f is all real numbers. We can plug anything we want into this. The range is all positive real numbers if a is positive. And keep in mind, this is before we move it around at all. It's negative if that leading multiplier, that a is negative. Our y-intercept here is going to be 0a, and our horizontal asymptote is y equals a. And so for which of the following represent exponential functions, this you know, right? It's a quadratic function, x to the second. So x is not the exponent. right? It's a power function, x to a power. B, also no. Because of the minus x part. So this is not purely exponential. This one's a yes. And this one's a yes. Okay. You could separate that -2 from the x and rewrite this with just the exponent of x as we saw above. So yes, this is an exponential function.